Thank you very much. Thanks. Thank you. I'm very, very happy to be here. I now have a Facebook page at the insistence of my publisher, and I announced on the page that I was speaking at the Linda Hall Library, and I put a picture of the History of Science section, and I got 4,000 reactions, which is far more than I usually get to anything I post. So you have friends everywhere. Somebody commented, "Tell me where they keep the coffee and then lock me in." My story about the glass universe is also about a kind of library, because a main character in this story is the collection of glass photographic plates started in the 1880s at Harvard and gathered over a period of 100 years, so that they total roughly 500,000 glass plates, which are all still kept at Harvard. And the title, The Glass Universe, and it struck me that the plates constitute a glass universe. And when I thought of using that as the title of the book, there was an obvious play with the glass ceiling, which was intentional, of course, but it has backfired on me because people often call the book The Glass Ceiling, which is really not the title. Even my editor at Viking Penguin. So, but we won't worry about that tonight. And as you heard in the introduction, the photographic plates gave a group of women a very unusual opportunity, because they were hired or brought in as computers. So they were doing the mathematical calculations that were always part of an astronomical observatory's work. The early observatories all had computers, but they were mostly men. So that term was really a job description before we had machines to do computing. But the plates turned the women's job into one of really making astronomical discoveries. And the director would often refer to the plates in bookish terms, that each plate was like the only existing copy of a valuable book that had to be carefully stored. There was a whole card catalog system, and readily accessed by anybody who needed the information. So this was the Harvard College Observatory in 1847, as you can see there. So it was a very stately looking building at the top of a hill, a little over a mile from Harvard Yard. And there were 2 telescope domes. And then in the other part of the building here, this was the director's residence. So he was right on site. And there was a real family atmosphere in the building. And the earliest female computers were really the family members of the astronomers, who would just rope the girls into doing whatever needed to be done, teach them how to make the calculations. And that worked out so well that it was a logical next step to hire people from outside. Edward Pickering took over at the observatory in 1877. He was only 30 years old, and he found 6 women already working there. And he had no problem with that. He came to Harvard from MIT. This is a picture of his lab at MIT. So he was a physicist, and he created this lab where students could actually learn themselves by doing experiments which he devised. And when young women came to him who wanted to take the lab course, he would let them in to do that. I'm going to go back here because there was a little concerned about his being a physicist. Was he really up to doing the astronomy? Most professional astronomical observatories at this time were involved in mapping the stars for navigation. But Pickering really was interested in the physics of the stars, and he was about to change things. The title of this book might give you the idea that it was a pro-women book. But really, it was an argument against higher education for girls. The idea was that if a young woman put all her energy into study at this crucial life moment, sorry, I have just something stuck in my throat, that she do physical damage to her body and that her reproductive organs would atrophy. Fortunately, we can afford to laugh. But Pickering thought that was ridiculous, and he not only embraced the idea of having women working in the observatory, but he also advertised widely for women who had been to college and studied astronomy and had access to a telescope, that he would tell them observations that needed to be made, and they could contribute to the work, and he would help them get their work published. So this was the main telescope at Harvard. It's a 15-inch instrument, and this was the telescope used to take the first picture of a star. That was in 1850. But the telescope really was not designed for photography. And Pickering right away got busy getting a smaller telescope that would really work to take pictures. And this is one of his early images. This is from 1888. You can tell it's from the constellation Orion. Sometimes they took pictures of transient phenomena. But most of the pictures are negatives. And they're all on glass plates that are roughly 8 by 10. Depending on the instrument, the plates could be different sizes. And Pickering had to fight a prejudice against the gimmickry of photography, because most experienced observers felt that this was an affront to their skill. Astronomers used to make observations and then draw what they saw. But Pickering's point was the photograph would create an irrefutable permanent record. And because the plate, unlike the human retina, could accumulate light over time, stars would show up in the photographs that no one had ever seen. And that eventually carried the day, and people accepted photography. This couple were amateur astronomers, and their love story really launched Pickering's major project. This is Dr. Henry Draper. Oh, look at that. How thoughtful of you. Thank you. I think I will. That's great. Whatever flavor, as long as they don't cough into the microphone. Thank you. So Henry Draper was a medical doctor, professor of chemistry, but a dedicated amateur astronomer who built some of the best telescopes of the day. And as an amateur, he was free to pursue whatever field interested him. And what interested him was the new area of spectroscopy. So taking the star's light, passing it through a prism to spread it out into a strip of color and lines, and really be able to discover things about the chemistry of the stars, things that people had thought would be impossible. How would we ever analyze the chemistry of the stars? And he said that the spectral analysis had made the chemist's arms millions of miles long. And the other thing that enabled him to do all these exciting things at the forefront was his wife, who was independently wealthy. And his partner in all his astronomical work. They were a team. And they succeeded in taking the first photograph of a stellar spectrum. So up to that point, people had been looking at the spectra in real time, drawing them, but never a photograph. And that was such an achievement that they decided to devote the rest of their lives to photographing the spectra of the stars and trying to create a classification system. Why do the stars appear different? Some are different colors. People understood there were varieties of stars, but there wasn't a way to get at what was causing the variety. And they were just about to do this. They had all their affairs in order when he developed pneumonia and died at age 45. So she, in her grief, swore that she would see his dream realized, and she thought she might carry it on herself with a few assistants, but she wasn't able to get the right qualified people. And so she asked Pickering, who was a friend of theirs, if he would take on this project, do the work in her husband's name, and she would give him her personal fortune to pay for it. So this is a textbook example of a spectrum. So you have the rainbow and then the dark lines that indicate the different chemicals. But there was no color photography, so the best of the images looked like this, the way Draper had been photographing them. And then Pickering, who was always very practical and in a great hurry to do the huge work of astronomy, he had the idea to move the prism to the light-gathering end of the telescope, and so he would get hundreds of spectra on a single plate. So each one of these little smudges is a stellar spectrum. This is a penny, just for scale. When I started working on this book, the first place I went was the Draper's private observatory in Hastings-on-Hudson. This is where he had his big, he had a 28-inch telescope that they started building together the day after they got married. And this building burned down, but this, the observatory cottage, is now the headquarters of the local historical society. And they had some original photographs and materials. But most of the Draper's papers are in the New York Public Library. Mrs. Draper was a great patron of the library, gave it many works of art and collections, and all of Henry's correspondence is there. And he was like Forrest Gump. He wrote to everybody, astronomers all over the world, and they all wrote back to him. So Mrs. Draper's money tripled the operating budget of the observatory at a stroke. And then she kept that up for 30 years. So Pickering was now free to hire a large number of women to analyze these plates. And this is how they would look at the plates. It's a little wooden stand, and the plate goes in here. And this is a mirror. So you have the shades open in the room, and the sunlight hits the mirror and bounces up through the plate for nice illumination. And then the analyst holds a magnifying glass. This is a special kind of microscope also for examining the plates. And then one person is doing the observation, calling out comments to a partner who makes notes in a logbook. And that was how they worked. This is a staged photograph. They weren't quite that cramped together in their work. So this is the woman who was standing at the back of the room, Williamina Fleming, who started her career at the observatory as a domestic servant. She was a Scottish immigrant and had come here with her husband. And then she found herself deserted and pregnant and desperate, so she took a job as a second maid in the residence side of the observatory. And Pickering noticed how smart she was and just moved her over to the observatory and taught her how to make computations and analyze plates. And then they helped her go home to Scotland to have her baby and promised her a real job if she would come back, which she did. And she spent the rest of her life at the observatory. She was the first woman to get a Harvard University title. The observatory was really separate from the university, but she was given this title as curator of astronomical photographs. She also made the first published section of the Henry Draper catalog of stellar spectra. She analyzed 10,000 stars for that publication. So this is just the floor plan of the observatory. So you can see they had a library and computing rooms. And then they had a problem because as the plates accumulated, first they were storing them in boxes, but they rapidly multiplied, and Pickering became paranoid about fire because the observatory was a wooden building. And in very short order, these plates were an irreplaceable treasure. And so he agitated to get them safe housing. And in 1893, put up this brick building. That's what it was called, the brick building, right behind the observatory. And that's where all the plates went to live. And the women, too, moved over there, so they were right with the plates all the time. At first, the women didn't have anything more than a high school education. Antonia Mori was the first one who came as a college graduate. She had gone to Vassar and studied astronomy. She had 8 semesters of astronomy with this lady, whom you may recognize. This is Maria Mitchell, truly the first lady of American astronomy. She became world famous after she discovered a comet in 1847, and then Matthew Vassar tapped her to teach at his college. Antonia Mori was also the niece of Henry Draper, so she had many reasons for getting that job. And she didn't think much of Mrs. Fleming's classification system. Mrs. Fleming had used letters of the alphabet to designate the different types of stars. Miss Mori was using more detailed pictures, and she created her own system with Roman numerals and subcategories. It was much more complex. So for a while, there were 2 systems being used in the same institution. Miss Mori's papers, I learned, were at the Library of Congress, a very, very grand, imposing building, but like most libraries, completely accessible. This is something that has been so meaningful to learn, and I always try to communicate to young people how doors fly open when you are interested in something. All you need to do research at the Library of Congress is to be 16 years old or older and be interested in something. That's it. And then everything that's there is available to you. Unfortunately, I didn't get to work in the beautiful part of the library. This is what the manuscript division looks like. And it's interesting how different archives have different codes of behavior. And at the Library of Congress, I had to turn out my pockets every time I left the room. I don't know what I could have had in my pocket, but so be it. Annie Jump Cannon was the first woman who came to the observatory with enough experience as an observer that they put her right on the telescope. She analyzed plates in the daytime, and at night she was making her own observations of variable stars. And part of the reason for that, she had been involved excuse me, in the physics laboratory at Wellesley, her college, and her teacher, Sarah Whiting, had been Pickering's student at MIT. So there was a nice connection there. And Miss Cannon is the one who took the two different classification systems and saw the best in each of them and made something that was better than either of them. And this is a typical plate that she worked from. So she would number all the spectra and then go through, as you saw in the stand with the magnifying, and just call out the number. And her system used letters of the alphabet. And she had to eliminate some letters, and then she re-alphabetized the alphabet so that it was no longer in alphabetical order. And it became O, B, A, F, G, K, M, or as generations of astronomy students have learned it, oh, be a fine girl or guy, kiss me. So, not for everybody, this work. One of the very fortunate things for me was the wealth of personal material preserved in the Harvard archives, including all of Miss Cannon's diaries. She was a lifelong diarist, and unfortunately her handwriting was terrible, but I got the hang of it, and these are just how they look in the boxes in the archives. So Pickering's vision, he had this grand vision. They were going to photograph the entire sky all through the night, every clear night, and keep it up indefinitely. And so to do the entire sky, he had to have another station in the southern hemisphere. And he sent this man, Solon Bailey, who came to him as an amateur astronomer. He sent him to South America to find a good place to do this. So this was the first Mount Harvard. Didn't look very promising, but eventually they got it together. And there are actually several telescope buildings here. Most of them have a slide-off shed roof. And this is El Misti, which was thought to be a dormant, an extinct volcano, turned out to be dormant. Inside the dome is this instrument. This is the Bruce Photographic Telescope. It has a 24-inch lens and was specifically created for taking pictures. And it's called the Bruce Telescope because it was the gift of another New York heiress, Catherine Wolfe Bruce. She became interested in astronomy when she was elderly, and Pickering went to visit her and told her he needed $50,000 to build this instrument, and she wrote him a check. He was very charming, very, very effective as a fundraiser. So here is Bailey again. It wasn't all work in Peru, it was mostly work, but he knew he would be there for years, so he brought his wife, Ruth Poulter Bailey, and they had a young son, about 3 years old when they left. So they made the trip together, and she worked with him. They were interested in the meteorology of the region. They set up several weather stations. She did a lot of that work, and she also helped with the astronomy. He was especially interested in these objects. These are called globular clusters. Astronomers are very clear about the way they name things. What else would you call it? I don't know. It's globular cluster. And Bailey, like Pickering, was very interested in variable stars, and he was astounded at the number of variable stars he would discover in these clusters. He also made counts of them. So you can imagine the meticulous nature of this work. So they would take a clear glass plate and rule it in 1 centimeter squares and place it over the photograph, and then count the number of stars in each square. Of course, when you get to the middle, it's impossible to count them. But he would count and she would count, and where they didn't agree, they would average. And then you have to go over pictures over time, over and over again, and judge the brightness of each of those stars, and then how it's changing over time. And most of the analysis the plates would get sent back to Harvard, and the team of women would really give them a thorough going over, but never a complete going over, because there was too much information in each of those plates. They have never been fully probed. The plates from the Bruce telescope were much larger. They were 14 by 17. So it doesn't look much different from the other picture I showed you, but this whole section had to be added in 1902 because they'd filled up the other building, and they were still going. This lady was the person I heard of first. She is the person who brought me to the story. I had been interviewing astronomer Wendy Friedman about her work as director of a key project on the Hubble telescope. This was more than 20 years ago. And she mentioned Henrietta Leavitt's name to me as someone whose work was fundamental to this Hubble telescope project on the expansion rate of the universe. This woman who'd lived more than 100 years previously. So that was interesting. And I went to learn more about Henrietta Leavitt, and that's how I discovered she'd been working in a room full of women at Harvard, which was really a stunning discovery because one doesn't associate Harvard with opportunities for women in the 1800s or even the 1900s. But there they were. So she was studying variable stars. And the way she would do that, she had these little miniature glass plates. These are all at most 3 inches wide. And they have on them images of stars. They're pieces of the photographic plates that had been cut up for this use. And they're stars where the brightness has already been determined. And they'll have little numbers written next to them for their brightness. And then she could put these down on a fresh plate and compare the stars on the plate with the stars on these little images. And that would hasten the work of determining all the brightness of all the different stars. And these were called fly spankers for their obvious resemblance to fly swatters. But the joke at the observatory was that they were too small to do a fly much damage. Now, this is one of the objects that Miss Leavitt studied that is visible only from the southern hemisphere. This is the Small Magellanic Cloud. And she was looking for variable stars in here, and she found hundreds of them. And she made a very interesting observation. She reasoned that everything in this cluster was roughly the same distance from the Earth. So that the things that looked brightest really were brighter than the other objects. Usually, if you're just looking at the sky, it's hard to tell what's bright because it's really big and bright, or maybe it's very, very close, relatively speaking. And as she followed the brightness changes over time, she noticed that the brightest stars took the longest time to go through their cycle of variation. And she published that finding, and it became the basis of the distance scale of the universe. So other astronomers immediately seized on this and first used it to determine the distance to the Small Magellanic Cloud. And the first estimate was 30,000 light years. It's actually more like 200,000 light years, but it was a start. And the calibration got better with time, but it was that observation of hers that really created the yardstick. I love this picture. Here's Miss Leavitt. This is Annie Cannon. And a couple of young women here are enjoying a new status at the observatory of being Pickering Fellows. Another heiress, a relative of Maria Mitchell, was so excited about all the opportunities for women at Harvard that she endowed a fellowship program that would enable a young woman to come in and work at Harvard for a year and then go get a job at another observatory. And that was part of a way of infiltrating the observatories with women. And Harlow Shapley, who took over when Pickering died, had another great idea of how to use the Pickering Fellowship money. But one of the first things he did was to use Miss Leavitt's stars to figure out the size of the Milky Way. He took part in an important debate about the size of the universe. Was the Milky Way the entire universe? Or were the little spiral shapes that showed up in a lot of photographs, were those things actually other galaxies very far away? And astronomers didn't agree on this. And even after the great debate, people didn't agree. Shapley thought that the way he measured the Milky Way, well, I'm getting ahead of myself here, I think. When he'd been working at Mount Wilson before he took over at Harvard, and he became very interested in ants, and actually wrote several scientific papers about ant behavior. And so I love this cartoon because I just wish he could have seen it. I've accidentally removed the caption. It's not a contest for you to come up with, although you are welcome to if you. But the caption that the cartoonist really intended was, "Makes you feel small, doesn't it?" So Shapley had been encouraged early in his career by Sobel and Bailey to study the globular clusters at Mount Wilson, where they had a really gigantic telescope. And he had done that. So now that he had Miss Leavitt's stars and this whole idea of a way to set distances, he looked at where the globular clusters were. And here's the sun. And they seemed to be circling a different part, that this X was really the center of the Milky Way. And he loved the idea that we were all the way out in the boondocks and we're not nearly as important as we thought we were. And he actually said, "Man is not such a big chicken." So this convinced him that the galaxy was so gigantic that it must be the complete universe. His idea for the Pickering Fellowships was to turn them into graduate student fellowships. Harvard was not training future astronomers. The observatory was in the business of producing knowledge. And he thought that was terrible, that they weren't training their successors. And he was determined to institute a graduate level program in astronomy. And the only money available were these Pickering Fellowships for women, which meant that the entire early class of graduate students were all recruited from the women's colleges. Adelaide Ames was the first one. She came from Vassar. Helen Sawyer from Mount Holyoke, and Cecilia Payne from Cambridge, England. This is the Schlesinger Library for American women at Radcliffe. So a lot of these, the papers of these early students were stored here, another very nice place to work. Miss Payne's story is really interesting because at first Shapley, the first couple of students went only as far as a master's, but Miss Payne was so brilliant and had such an interesting project that he pushed her to go all the way through for a PhD. And she had wanted to come to this country because she'd already been told that there was no future for her in England as an astronomer. And she'd heard Shapley lecture when he was visiting London, so she spoke to him, told him she wanted to come work for him. And she also wanted to work with the plates because at Cambridge, she had learned the new atomic theory. And she thought she could apply that to the spectra on the plates and figure out the relative abundance of the different elements in the stars. And since so many of the materials were the same as appeared on Earth, the expectation was that the abundances would be similar. And when she really got rolling, she kept getting these ridiculously high percentages of hydrogen. And in her dissertation, she wrote that for some reason, hydrogen seemed about 1 million times more prevalent than anything else. And Shapley worried about that, so he showed her draft to the reigning authority, who was his mentor at Princeton, Henry Norris Russell. And Russell said, it's impossible for hydrogen to be that much more abundant than everything else. So they told her to not make too much of that in her thesis. But she did publish it. She said it was probably wrong, but that nevertheless it was her finding, and maybe at some point the reason would become clear. But having called attention to it, Russell himself really did a lot of the work, and it took only 4 years for him to convince himself and everybody else that it really is mostly hydrogen and helium. So she was the first person to earn a PhD from Harvard in astronomy. They had a lot of fun at the observatory. Here's Miss Payne again, starring in the only production they ever did of the Observatory Pinafore, which was just a great spoof about how astronomers don't make any money and other topics. One of the things I found in the archives at the Schlesinger was this object. Miss Cannon, in her later years, was given an award by a group that had been formed to recognize women's achievements in science. And after they gave her the money, they disbanded. And she felt that the work wasn't really done. So she used the money to create her own prize, the Annie Jump Cannon Prize. And her idea was that it would be awarded every 3 years by the American Astronomical Society, of which she was not only a member but an officer. And she thought that in addition to money, she would also, at her own expense, have a piece of jewelry created for the winner. And so each time that the prize was awarded in her lifetime, she commissioned a woman jeweler to make a universe. And this was the one that belonged to Margaret Harwood, one of the earliest Pickering Fellows. This is where the plates are stored in the even further expanded brick building. So these are 2 photographs of the same young woman who was the current curator. Her name is Lindsay Smith. The curator has always been a woman since Mrs. Fleming's day. And here she is examining the logbooks where they made all the notations. If you have time on your hands. All of these need to be transcribed. I'm not joking. There really is an ongoing crowdsourced platform for doing this. And these are the plates. This is how they're stored. Each one has a paper jacket, and they're very carefully filed for the most part. You know, even in a great library, sometimes things are misshelved. And this is how the plate stacks looked on the morning of January 16th, 2016. For all that Pickering dreaded fire, never occurred to him that the plates could be damaged by a flood. And a water main burst under the building and submerged about 60,000 of the plates. And there had been a program in progress for years to digitize the plates because they are still used. And rather than have people come to Harvard and handle the fragile plates, having them in digital form has been considered a really good idea. So not only were the plates submerged, but all the specialized equipment that had been built for the digitization project was also ruined in the flood. So the conservation people at the university said, the first thing is just get them someplace where it's dry and cold so we don't get mold on them. And volunteers came in, carried all 60,000 plates up outdoors. It was January, so it was cold, and fortunately it wasn't raining or snowing, so outside was just the right place for them to be. And then they were all taken by truck to a special preservation center where they were kept in freezing conditions, and they've started to come back now. And most of them are fine. And the new scanning equipment is faster, so they'll probably catch up and not lose too much of their progress. How many have seen the movie Hidden Figures? Yeah. So I like to say that my ladies are the grandmothers of the Hidden Figures. I think why would NASA have hired all those women as calculators if there hadn't been the precedent set at Harvard? And this is Alyssa Goodman. She is professor of astronomy at Harvard. I point out, this looks like a NASA t-shirt, but it actually says nasty. And Alyssa was one of the people I approached as a technical expert to read the manuscript for me and look for astronomy errors. Bill Ashworth here at the library is another one. Thank you again, Bill. And Alyssa got completely sidetracked by the story. She dropped her responsibility as a bona fide astronomer and could not get over the story of the women. And she said something to me that exposed, I think a lot of women are not aware of how much misogyny we've absorbed, because she said, I always had the idea that they had just been doing something cute or quaint. I never realized they were doing serious science. And then she said, we need you to come up here and teach us our history. So she arranged for me to have the book launch party in the observatory. So here they are, and they love taking these tableau pictures and posing. This is Margaret Harwood, who's Annie Jump Cannon Prize. She went on to become she was the director of the Maria Mitchell Observatory in Nantucket for 40 years. This is Antonia Mori. This is Cecilia Payne. Here's Annie Cannon, too busy to look up, you know. And I just feel really good about having told this story. I was amazed that no one had told it before. George Johnson had written a book in 2005, I think, called Miss Leavitt's Stars, about Henrietta Leavitt. But I wanted the whole story with the plates and all the things that they made possible. And they are still important. There's something called time domain astronomy. And being able to look back at what the sky looked like 100 years ago turns out to be really important. And the Harvard collection is a unique resource. And another reason I feel good about having told the story is just the way the times look when the book came out. There is a backlash, an anti-science backlash. And I'm afraid that's getting a lot of encouragement in an age of fake news and alternate facts. And I feel really good about having told a true story about science, especially a true story about women in science. And I hope you will enjoy that story with me and pass it on. And another thing I'd like you to pass on, Henrietta Leavitt's discovery for many years was called the period luminosity relation. But for almost 10 years now, starting at Harvard, astronomers have been calling it the Leavitt law. All right? Pass it on. Thank you. Can we take questions?
Yep, we have time for questions. Before the book signing starts, raise your hand. I'll come by with a microphone.
What about the director of the observatory after Shapley? How did things change after that, and what was going on?
How did they change after Shapley? Well, I do take the story up to about 1950, but there was a little less interest in the plates. Some of them were deaccessioned, probably the poor quality ones, but there are varying stories about that. And then the observatory was very actively engaged all through World War II. Many of the astronomers were teaching celestial navigation at the university. Shapley was called to the House Un-American Activities Committee for his activities trying to bring foreign astronomers here. And was there something particular you wanted me to?
No, I was just wondering how things changed after that particular director.
Well, things progressed. Miss Payne became a full professor of astronomy. The directors of the observatory kept up that feeling. The presidents of the college, of the university, however, had varying effects. So although Mrs. Fleming had gotten a university title in 1900, by the time Annie Cannon took over, there was a different president who didn't feel that should be a university title position and just made it just another job at the observatory.
I would like to ask the question, in all of those diaries and reference material you went through, what was your best goosebump moment?
Okay, great. Well, there was a big goosebump moment just opening the box and seeing what the diaries looked like. There was something, so maybe I can go back to that because some of them, sorry, there it is. Some of them are just very girlish with a lock and key. Some of them are all business, a 5-year diary where there was just room for a paragraph each day. And then this was her book about her grand tour in Europe after she finished college, with all kinds of mementos stuck in it, menus and pressed flowers. And of course, I went right to her diary from 1920 to see if she voted as soon as she could, and sure enough, yeah, she did. She would. And the other was realizing how the Pickering Fellowship created the opportunity for graduate level education for women, that all the early graduate students were women. It took a few years before they had funding for a program for men. Before that, they would just refer the men to Princeton or some other college because they couldn't give them any funding.
Dava, a question in the back of the room?
Actually, two questions. First, you alluded to the fact that they're digitizing all these photographic plates. Can you give us first an idea of the percentage of the plates that they've digitized? And secondly, have essentially digital photography techniques completely subsumed the creation of original glass photographic plates?
I'll answer the second question first. Yes, nobody takes glass plates anymore. What is the percentage? I was just there last week, and I was given a percentage number, but I have forgotten it. If you leave me your email, I'll let you know. But you can probably get the answer online. The project is called DASH, Digital Access to a Sky Century at Harvard. And the data releases, I mean, a lot of the data have already been released. So you can look at it. You can see the plates. And the way it's done is not just the pictures. It's the magnitudes of all the stars. There are many ways you can get the information.
Over here on your left.
Yes, my question is, you made reference to they didn't want women to be in the profession because they were scared it was going to ruin their womanliness. So did these women go on to have families and kids, or were they just committed to this profession then?
Well, first of all, as you probably know, going to college does not prevent a woman from having children. That became clear. In the early days, it was very unusual for a married woman to work. I mean, Mrs. Fleming was working because her husband was gone. The women in the observatory who married left. But most of them didn't leave. Most of them were there for 30, 40, 50 years. So they really loved what they were doing. They were fully engaged. And I know the atmosphere was very collegial. They worked together 6 days a week, and then they socialized on Saturday night. Later, in the 1920s, when the graduate students came, then two of the graduate students married each other. And they didn't stay at Harvard, but they both stayed in the field and were able to both continue working. And more. And then Cecilia Payne married and managed to bring her husband to Harvard, and they both continued there. So as the times changed, the opportunities to keep a job and be married changed. I should mention that Mrs. Fleming brought her son, she left her son with her family till he was about 7 in Scotland. But then her mother moved here with him, and she was able to put him through MIT, and he became a mining engineer.
Hey, Dava, in the back of the room on your left.
What was your favorite part of the research for the book?
I think my favorite part was reading Miss Cannon's diaries. And sometimes she wrote a little a Christmas poem for her friends that she would send everyone as a Christmas card. A little story of starlight. You would have loved to have gotten one of those.
Stay up front here on your left.
At the time, was there any collaboration between the Harvard Observatory and other observatories around the world? And did the women somehow get involved in that collaboration?
Astronomy was extremely collaborative, and Pickering had a grand vision of having everybody participate in the work. They started having meetings. What's now the International Astronomical Union grew out of those early meetings. They would be writing to each other, even bringing astronomers from Europe here for meetings, or Americans going to Europe. Very early on, Mrs. Fleming was made an honorary member of the Royal Astronomical Society. So the women were given credit for what they did, always in the publications. And so they were world famous in their own lifetimes. It's not that they never got credit, it's just a forgotten story. And several of them, in fact, became honorary members of foreign astronomical societies, in addition to being members of the American one.
All right, Dava, thank you for a wonderful lecture.
Thank you.
And thank you for attending tonight's program. Don't forget our upcoming events that Lisa mentioned earlier in her introductions. And please, we'll start the book signing in a few minutes, so please get your copy of The Glass Universe. Rainy Day Books has several of them available. So thank you again, and good night.